All right, so this is a example of does this problem have a greatest common factor? Well, goodness, it's a trinomial. I see that. And this is 2 times x times x times x. Okay, then I've got the plus 2 times 3 times x times x. Then I've got the minus 36. Boy, that's got lots. It's definitely 2 times 3 times 3 times 2, I think, times x. 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. Okay, so what you should see here is, let me get a different color. I've got a common factor of 2 in each one of these, so a common factor of 2. I also have a common factor of x. Each one of those has a common factor of x. So it looks to me like my GCF is 2x. And the remaining stuff, if I factor out the 2x, I'm left here with an x squared. If I take away that 2x, I'm left with 3x. And if I take away the 2 and the x, I'm left with 2 times 9. I'm left with 18. Okay, so is there a greatest common factor? Yes. Factor out the GCF. So I factored out the 2x. And now I'm answering questions about the quotient. Okay, the quotient, how many terms does it have? This one has 3 terms. Is it a perfect square trinomial? Is 18 a perfect square? No, it's not on that list. So the answer is no. Is the leading coefficient or the A, is A equal to 1? A is equal to 1. Yes. Then I factor it the easy way. And I'm just worried about the trinomial. So I need factors. I need a factor sum table. Factors of negative 18. And those are going to have a sum of positive 3. So factors of negative 18. So let's see, what about negative 2 times 9? Those multiply together to give me negative 18. But a negative 2 plus 9, that's going to give me a 7. It's supposed to give me a 3. All right, so, and if I try positive 2 times negative 9, I still get negative 18. But a positive 2 plus a negative 9, that's just going to give me a negative 7. So what about 6 and 3? Positive 6 times negative 3. That's going to give me a negative 18. A positive 6 plus a negative 3, that's going to give me a positive 3. So it looks like I got the sum of 3 here. So these are my factors. So the 2x stays out there. X plus 6 is one of my factors, and x minus 3 is the other factor. The 2 x's come from here. X times x is what gives me x squared, and positive 6 times negative 3 will give me negative 18, and the positive 6 and the negative 3x will add together to give me a positive 3x. So this is the positive, or is the complete factorization of this problem right here. I started out, got the GCF out, determined it still had 3 terms. It was not a perfect square trinomial, but the leading coefficient, the A term, was 1. So that means it's a factor sum table. He calls it factor the easy way. If you rather change yours to the factor sum table. This is supposed to be something that you do for yourself. So if it makes more sense right there, instead of you saying factor the easy way, you can write the factor sum table. And that leads us to what do we do? Oh, and by the way, be sure you understand this. This is saying that, notice the a is 1, so that's why they have the 1x squared plus bx plus c. And they said these two numbers are going to be your factors, given that B right here is what you get when you add these two right here, P and Q, when you add P and Q, and C is what you get when you multiply P times Q. So in the factor, in the factor table, we multiply P times Q, and then over here for the sum, we get P plus Q. This gives us B, and this right here gives us C. So in our factor sum table, we put the C always goes right here. Notice the 18, this is the C, that goes right there. And the sum, this is our B, it's what went right there. So C goes here, B goes there. And whatever numbers we multiply together, we put right there. We follow the sign rules as they appear in the problem. We just, we change the pluses and the minuses so that they match the outcome over here. Okay, so my last set of videos will be over what do we do when A is not 1. Okay, when A is not 1. That's what the last set of videos are going to be about.